Dear students, today we are going to discuss the concept related to the topic applications of derivative. As we know that in applications of derivative, we have to study the meaning of derivatives, then increasing and decreasing functions, maxima and minima, and application of derivatives to economics. In last lecture, we have completed the meaning of the derivatives. In that, geometrical meaning of derivative is completed. That is how to find out the equation of tangent and normal to the given curve. Also, we have completed the exercise number 4.1. Today, we will discuss how to decide the increasing and decreasing functions by using applications of derivatives. So let us see now. First of all, we will see the definition of increasing function. See the graph here. The graph shows that the function is increasing. See how it is increasing. Here it is in the definition, it is given that the function y is equal to f of x is said to be an increasing function of x in the interval a to b if f of x2 is greater than f of x1. See here in this figure, here there is f of x2 and this is f of x1, and in this case f of x2 means value of y means f of x. So f of x2 is greater than f of x1 whenever x2 is greater than x1 in the interval ab. That means what? Whenever you increase the values of x, we get the corresponding increase in the value of y. So see here it is mentioned that geometrically, as we move from left to right along the curve y is equal to f of x in AB, then the curve rises. See, this is the rise of the curve. Whenever you move from left to right, the value of x increases, and as y depends on x, because y is equal to f of x is the function, so as y depends on x, value of y also increases. So that's why it is called as increasing function. So by using the concept of the derivative, in this case the slope of the tangent at point x is, that is f dash x, is always greater than 0. Means whenever you take any tangent at any point here on this curve, this is the curve, that is it is an increasing function. So if you take any tangent here, then the slope of the tangent will be always positive. Okay, so if f dash x is greater than 0 for all x belongs to AB, then y is equal to f of x is an increasing function in the interval a comma b. So note that sign of the derivative can be used to find if the function f of x is increasing. Okay, so what we have to remember, the function is increasing when f dash x is greater than 0 for all x belongs to that interval. So remember the definition of increasing function, and this is the graph of increasing function. Okay, now we will discuss same about the decreasing function. See, this graph shows the decreasing curve. See here, from a to b curve decreases. So how will you write the definition? See here, a function y is equal to f of x is said to be a decreasing function of x in an interval a to b if f of x2 is less than f of x1 whenever x2 greater than x1 for all x1 x2 in that given interval. Means whenever from left to right the values of values of x are increasing, but at that time values of y are decreasing. See, for x1 there is f of x1 and for x2 there is f of x2. Here x2 is greater than x1, but f of x1 is greater than f of x2, or you can say f of x2 is less than f of x1. See the figure carefully, you will get the clear idea about this. This is the decreasing function. So geometrically, as we move from left to right along the curve y is equal to f of x in AB, then the curve falls. Okay, so by using application of derivative, how will you decide the function is given function as a decreasing function? If the slope of the tangent to that curve is f dash x, which is always less than 0, means whenever the slope of the tangent is negative, then you can say that the function is decreasing function in that interval. Okay, so remember, here the curve decreases, means values of x are increasing but values of y are decreasing. That's why this function is called as decreasing function. Now let us solve the exercise number 4.2. The concept is very simple. See, question number 1 is given that test whether the following functions are increasing or decreasing. Three functions are given to you, which is defined on R, real number, and we have to decide whether the functions are increasing or decreasing. So try to solve these three questions. Very simple. So let us see. Now first function is given f of x is equal to x cube minus 6x square plus 12x minus 16 for x belongs to R. Now see how will you solve this. So in answer, first of all write down the given function. Given is f of x is equal to x cube minus 6x square plus 12x minus 16. Now we have to decide whether it is increasing or decreasing on the real line. So for that, first of all we have to differentiate this with respect to x. So differentiate with respect to x. Then what will you get? F dash x. So here it is 3x square minus, now this here x square is there, so derivative of x square is 2x. So 6 into 2, that is 12x, and plus derivative of 12x is 12 minus derivative of 16 is 0. Now see, we get the f dash x. Now we have to decide on the real line whether it is this f dash x is positive or negative. That we have to decide. Okay, so for that we will modify this first of all. This is the quadratic equation. Here you will get 3 common. So x square minus 4x plus 4. Now for every value of x, means if you put any value of x, that is any real number if you put here, then either it will be you will get the f dash x negative or you will get the f dash x positive, and depending on that we have to decide whether it is increasing function or decreasing function. So now see here, 3 is always positive, no doubt. Okay, but what about this quadratic equation where it will remain positive or negative? How will you decide? So for that, if you observe this carefully, then see here, x square minus 4x plus 4 is the square of x minus 2. It is the square of x minus 2. Now if you see this expression, then here in this case 3 is positive, and if you put any value of x here, x minus 2 will be always positive, because square of every real number is always positive. Square of every real number will be always positive. So you can say that this f dash x, our modification in f dash x is what? 3 into x minus 2 bracket square. 3 is positive and x minus 2 is also positive, which is greater than 0 for all x belongs to R, and for x is not equal to 2, because for x is equal to 2 it will become 0, but overall for all x belongs to R x minus 2 bracket square is always positive. So we have to mention that particularly for all x belongs to R, where x is not equal to 2, because if you put x is equal to 2 here, then it will get 0, and 0 is not neither negative nor positive, but you can say that this function is increasing. So hence, as f dash x is greater than 0, so we can write that given f of x is increasing for all x belongs to R. Okay, so this is the final answer. Okay, now see the next question. Next function is given f of x is equal to x minus 1 upon x, where x belongs to R and x is not equal to 0. Why x is not equal to 0 is given? Because if you take x is equal to 0, then f of x is equal to x minus 1 upon x cannot be treated as a function, because for x is equal to 0, value of f of x does not exist, because it will become 1 upon 0, and 1 upon 0 is not defined. So specifically here compulsory we have to mention that x is not equal to 0. Now we have to check that whether the function is increasing or decreasing. So for that, write given that f of x is equal to x minus 1 upon x. Now first of all, differentiate this with respect to x. Now you will get f dash x. Now just take the derivative. Derivative of x is 1 minus derivative of 1 upon x. All of you know that it is minus 1 upon x square. Check this. So finally you will get 1 plus 1 upon x square. 1 plus 1 upon x square. So this is our f dash x. Now if you observe this carefully, for all x belongs to R, here see 1 is positive number, plus here it is 1 upon x square, and for every value of x, x square is positive. X is not equal to 0 is given to you. Okay. So 1 upon x square is positive. So totally you can say that this f dash x, which is 1 plus 1 upon x square, it is always positive for all x belongs to R, because we have to decide for x belongs to R. So we can say that for all x belongs to R, 1 plus 1 upon x square is always positive, where x is not equal to 0. So hence we can say that given f of x is increasing function for all x belongs to R. Okay, so this is our final answer. Now see third one. F of x is equal to 7 upon x minus 3. Here also x belongs to R and x is not equal to 0, because for x is equal to 0, this function cannot be defined. Okay, so see how will you check that the given function is increasing or decreasing. So write down given function. Given f of x is equal to 7 upon x minus 3. Now differentiate this with respect to x. So you will get f dash x. Now see how will you take the derivative of 7 upon x, 7 as it is, and we have to take the derivative of 1 upon x, that is minus 1 upon x square, minus derivative of 3 is 0. So totally you will get the derivative as minus 7 upon x square. Now for all x belongs to R, you have to decide whether it is negative or positive. Now if you put any value of x here, then x square is always positive, but minus 7 is there. So due to minus 7, this function means this f dash x remains negative always. See, minus 7 upon x square is always negative, because x square is positive but minus 7 is always negative. So minus 7 is negative. Negative upon this positive number. Negative upon positive means negative. So that's why minus 7 upon x square is less than 0 for all x belongs to R, where x is not equal to 0, and hence as the f dash x is negative, you can say that given f of x, given f of x is decreasing function, decreasing function for all x belongs to R. Okay, so we have to decide whether the function is increasing and decreasing by using the application of derivative. Means just you take the derivative of the given function and then try to decide whether that f dash x remains positive or remains negative for all the given points. Okay, so this is the main technique to decide the function as increasing or decreasing on the defined interval. Okay, so thank you all of you.